This lesson is on multiplying polynomials, so we're going to go through how to multiply binomials and other polynomials. First, we're going to talk about binomials, and we're going to use the FOIL method, which means that we multiply first, outer, inner, and last terms. You can also use the box method for this. So looking at the first example, we're going to go through the FOIL method first and then the box method. So the FOIL method says that I multiply the first terms, so that would be 56n squared. The outer terms, so that would be negative 21n. The inner terms, so that would be positive 64n. And the last terms, that would be negative 24. And then all we have to do is simplify them, so that becomes 56n squared plus 43n minus 24. Now if we were to use the box method for that, we're going to put each term on the outside of the box. Make sure you include the sign. And then we're going to multiply. So this box is 8n times 7n, which is 56n squared. 8n times 8, which is 64n. Negative 3 times 7n is negative 21n. And negative 3 times 8 is negative 24. So then I'm going to combine everything. So that's 56n squared minus 21n plus 64n minus 24. So as you can see, that ends up being the same thing as it was when we used FOIL. In the next example, we're just going to use the FOIL method. So we're going to multiply the first terms. So that becomes 8x squared. Then the outer terms. So that's negative 10x. The inner terms, which is positive 4x. And the last terms, which is negative 5. And then I'm going to drop that extra 3 from the outside and distribute it. So here I've got 3 times 8x squared minus 6x minus 5. And now I can just distribute that 3. So I don't have to worry about it until the last step. So that becomes 24x squared minus 18x minus 15. And that would be our final answer for that example. You could also use the box method for that. Just save the 3 for the last step, like we did with FOIL. Now here are some practice questions for you to go through on your own, and then we will go over them as a group. Now going over these, I'm going to use the FOIL method. So in the first practice question, it would be 5x times 7x, which is 35x squared. The outer terms would give me negative 10x, the inner terms positive 14x, and the last terms negative 4. So that's 35x squared plus 4x minus 4. And the next example, first terms would be 7m times 2m, so that's 14m squared. Outer terms would be 7m times 5n, so that's positive 35mn. Inner terms is negative 10mn. Last terms is negative 25n squared. So when I combine my like terms, those terms in the middle, that's 14m squared plus 25mn minus 25n squared. In the last example, the first terms would give me 12a squared. Outer terms would be negative 16ab. Inner terms would be negative 48ab. Last terms, positive 64b squared. So when I combine my like terms, I'll have 12a squared minus 64ab plus 64b squared. The next thing we're going to look at is multiplying polynomials other than binomials. We're going to use the distributive property to make sure that all terms are multiplied by each other. And for this one, I would use the box method. It's a good way to make sure you don't forget any terms. So looking at the first one, that's a 2 by 3. So on top, I'll have negative 2a squared, negative 4a, and negative 8. And on the side, I'll have 6a and negative 6. And I'm going to go through and multiply each of those. So in this first box, it's negative 2a squared times 6a. So that's negative 12a cubed. This one would be positive 12a squared, negative 24a squared, positive 24a, negative 48a, and positive 48. So I can write that out as negative 12a cubed plus 12a squared minus 24a squared plus 24a minus 48a plus 48. And when I combine my like terms, I get negative 12a cubed minus 12a squared minus 24a plus 48. And that would be my final answer. In the next one, we have a 3 by 3. So on the top, I'll have 3k squared, 3k, and 6. No need to include the signs when they're positive. And on the side, I'll have 5k squared, 3k, and 3. When I multiply this out, I'll have 15k to the 4th, 9k to the 3rd, and 9k squared. 15k squared, 9k squared, and 9k. Excuse me, this one should be to the 3rd. This will be 30k squared, 18k, and 18. So when I write that out, I'd have 15k to the 4th plus 9k cubed plus 15k cubed plus 9k squared plus 9k squared plus 30k squared plus 18k plus 18. So I can combine lots of things here. Basically, if the exponent is the same, it can be combined. So that's 15k to the 4th plus 24k cubed plus 48k squared plus 18k plus 18. Now I want you to try these ones on your own and we'll go over them. Going over this first one, we have a 2 by 3, so 4x squared, 3x, and 5, and 4x and 8. When I multiply them out, I get 16x cubed and 32x squared. Here I get 12x squared and 24x, 20x, and 40. So that becomes 16x cubed plus 32x squared plus 12x squared plus 24x plus 20x plus 40. So I'm going to combine my like terms, and I end up with 16x cubed plus 44x squared plus 44x plus 40. The next one is the same concept, only it's a 3 by 3. So 6n squared, negative 5n, positive 6, 8n squared, 4n, and 6. So this becomes 48n to the fourth, 24n cubed, 36n squared, negative 40n cubed, negative 20n squared, and negative 30n, 48n squared, 24n, and 36. So 48n to the fourth plus 24n cubed plus 36n squared minus 40n cubed minus 20n squared minus 30n plus 48n squared plus 24n plus 36. And remember, you can only combine the things that have the same exponent. So in my final answer, I'll have 48n to the fourth. The n cubed that I can combine will be 24 and negative 40. So that ends up being negative 16n cubed. I can combine 36n squared, negative 20n squared, and positive 48. And that leaves me with positive 64n squared. I can combine negative 30n and positive 24n, which is negative 6n plus 36.